Good morning, and welcome to this webinar on NPI performance that matches plan and avoid the Tightwire. I'm Robert Zwerling. Before we get started, a couple of notes. First, to ask a question, please use the chat box, and we'll get into those questions at the end of the webinar. And second, the webinar is being recorded. So anyone who registered for the webinar will receive a link to the recording. So let's get started. The scorpion is, I think, a perfect expression of the pain of NPI demand forecasting, because we often get stung by the struggle to give the CEO a commitment of our shipments. We also get stung by sales forecasts. Our sales departments give a forecast. The forecasts aren't detailed. They're not at the customer product level, and they're often in dollars that we then have to translate to units. We're not sure if we have excess or insufficient material and products. We lack confidence in demand, so we struggle to control costs. There's always the issue of stress with our staff, because a lot of the things that we do lack automation. And finally, we're in a constant guessing game. Forecasts are ever changing. We expect some of that to happen. Unfortunately, it happens to a larger extent than oftentimes we can manage. So this is the pain that we suffer and we go through every time we go through releasing a new product. So our agenda today is going to be, why is new product introduction so uncertain and painful? We're going to discuss a solution. We're going to move from what's known as deterministic forecasting to probabilistic forecasting. We're going to see an example using Aurora Lights of a probabilistic forecast with a $750 million CPG manufacturer. We were able to use AI demand forecasting to reduce inventory on hand by $90 million. We're also going to talk to and list the gains we get from probabilistic forecasting and scenario planning. And finally, how to start probabilistic forecasting. So just an introduction. I'm Robert Zwerling. I'm Managing Director of Aurora Predictions. I'm also the co-managing director of the Finance Analytics Institute. I have 25 years founding, growing, and exiting software companies across manufacturing, distribution, telecommunications, high data availability, and of course, analytics and AI. I have over 1,000 plus analytics projects. I've co-written over 100 papers and articles on analytics. I've been a global speaker and lecturer. I've written these two books that you see here, Implementing an Analytics Culture for Data-Driven Decisions, and the latest book, AI-Enabled Analytics for Business, published by Wiley, that was just released last year. As mentioned, I am Managing Director of Aurora Predictions. At Aurora, we have our intelligent analytics, forecasting, and planning platform to enable unbiased decision-making across sales, finance, supply chain, and operations. We have an intuitive and zero-code user interface, which means there's no need for data science skills, or statistics skills, or IT support. As mentioned, I'm also co-founder and co-managing director of the Finance Analytics Institute. And there we teach how to implement analytics through articles and research papers. We have our well-known benchmark analytics survey and our highly rated Analytics Academy. I have a Bachelor of Engineering, magna cum laude, in mechanical engineering. I have a Master's of Science in mechanical engineering, majoring in thermodynamics and fluid mechanics. And I'm a licensed professional mechanical engineer in the state of California. So with that, why is NPI forecast accuracy a struggle? Well, several reasons. First, as mentioned earlier, we often start with a high-level forecast that's in dollars, not in units. Now, what we do also do, and is the preferred way to do it, is start with a surrogate product. We say this product is very much like the NPI product that we're going to introduce. And therefore, we now have at least a product that we use as a surrogate, and we have it in units, the better way to start. From there, though, we get into certain issues, because the forecasts that we make with the surrogates are made with spreadsheets or business intelligence tools or data visualization tools or budgeting planning tools, and then they're modified by gut feel. A problem with gut feel is it's biased and not data-driven. And the result is what we get is a biased, deterministic, which is a single point forecast, and I'll explain that in a moment, which is undoubtedly wrong. So what's the solution? Well, the solution is having a probabilistic forecast along with scenario planning that we do with analytics tools. In other words, we bring the right tool to solve the right problem. So first of all, what is probabilistic forecasting? And for that, we need to start with deterministic forecasting, which we're all familiar with. We may not be familiar with the name, but we're all familiar with what we do, which is a single point value at a single point in time. And from that, we do all our planning, the single point value, which is almost always wrong at the single point in time. What we want to move to is what we call a probabilistic forecast. And here we take the same deterministic forecast, which is seen by this central purple line here. And now we run something very popular called the Monte Carlo simulation to give us a probable range of outcomes. So rather than 1 point value forecast at 1 point in time, we're now getting a forecast range with a probability. So what do I mean? Here in the yellow band, this is our first confidence interval, we have a 68% probability that the future will actually fall in this range. So we have a 68% probability that the future will fall in the range, and an 84% confidence probability that the future will not exceed the top of the yellow band. Now, the next band is the orange band, where we have a 95% confidence that the future won't fall outside the orange band. And the red band is the 99% confidence interval that the future will not exceed the top of the red band. So we've gone from 1 point value forecast to a range of forecast with a probable outcome. So rather than saying we're going to plan to a point value, we say we're going to plan to a range, oftentimes the yellow band, which says our planning band is going to be not less than bottom of the yellow band and not more than the top of the yellow band. And we're going to do this, by the way, all throughout the dimensionality of our business. So at company level, at any region or state or city or customer or store with each new product. So we have a planning band that's granularly dispersed throughout our business. So again, moving from 1 point value that's almost always wrong to a planning range. Now, the power of the planning range is twofold. Suppose our NPI, we think about our customers, and with a particular customer, we have, let's say, a 95% SLA. Well, if we have a 95% service level agreement, we're going to use for that customer the orange band, because that orange band is our 95% confidence interval. Now, also think about it with regard to inventory. In inventory, we think about static min-max. Now, the max will also be determined, usually determined statistically, but in this case, like for this particular product, our max is about 6,000 units. But But that 6,000 units only happens in June and July of our forecast. So if we have 6,000 units statically across the year, we're tying a lot of money up in our inventory. With this type of probabilistic forecast, we can have dynamic min-max. So yes, we need 6,000 in June and July, but if we go down to February or March, we only need 4,750 at the top of the third confidence interval. So by doing this, by varying our min-max, we assure our probability, but we do it at a lower cost, anywhere ranging from 2 to 10% of inventory on hand, we can reduce by varying our inventory min-max dynamically. So probabilistic forecasting moves us from a single point value to a range, takes us from one forecast to as many as 3 probable range forecasts. Now, as I said before, probabilistic forecasts require analytic tools. You're not going to do this in Excel. You're not going to do this in BI tools. You're not going to do this in planning tools or your ERP systems. You need to bring the right tools to bear in order to do your probabilistic forecasting. So let's talk about what we do here at Aurora Lights in our probabilistic forecasting and scenario planning. So first, we say start with a surrogate product. Now, you may say, Robert, that's great, but you just told me that that's biased. Yes, it is. But this is one thing that humans do well. We're very good at our business. We're very good intuitively at our business. And we're very good at selecting like products. So our new product is most like this one product or these several products. But we can do that well. We can select a surrogate. And that's the best place to start. Now, once we have the surrogate data that we're going to use for our launch, we do something called triangulation. And the first thing is collaboration. We want to make changes to that forecast. But instead of making bias changes, we want to make changes to which we know something definite about. For example, we need to have 500,000 units of our product in Europe in the first quarter. And we know we can't supply 500,000 units in Europe because of our capacity. It's constrained. We simply can't do it. I mean, so we obviously have a choice, add more capacity. But if we don't, we say, well, we can do 400,000, but we can't do 500,000. So in this collaboration, we're adjusting the forecast to what we can deliver. The second part, which is very interesting, is what we have is called the AI lead indicator. We use here artificial intelligence to find external lead indicators. External indicators would be things like unemployment or consumer sentiment, producer price index, and so on and so forth. And we use this to find where those are correlated, where they're lead indicators, how long are they lead indicators by 3, 4, 5 months, how strong is the lead indicator, and the direction of the lead indicator. Are they correlated directly or indirectly? And with that, we also make another forecast, but this one is generated by the AI. So we can compare now the surrogate forecast that we started with our collaboration, compare it with the AI lead indicator forecast, and whenever they fall outside a particular statistical range, we set that aside and we study it further. The rest we accept. Now, the next thing we do is simulate. Now that we have collaboration and lead indicators, we take that and we run that through a Monte Carlo simulation like we saw before. Because we've also, developed and found lead indicators of our business, now we can do some very interesting scenario planning. So for example, if we're correlated with, let's say, consumer price index, we can run a simulation that says, well, what happens if our consumer price index goes up, or what happens if our consumer price index goes down, what would our forecast look like then? So we can run these scenarios. And the reason we're running these scenarios is because we're trying to plan for the future. And that takes us to monitor the forecast. So along the way, we're going to measure our actual outcomes against our forecast. And when we see they're skewing outside our planning ranges, we can flip to one of our scenarios that better meets the forecast. So rather than reacting to the future when it arrives, we're planning for the future. Very different, very powerful. The other thing we're doing is detailed life cycle analytics. And let me take you to that now. So this is an example in lights of what we call a drill path. Now, this drill path divides the data, in this case, of a manufacturer of business and consumer electronic products into its life cycle stages of early, adolescent, mature, and end of life. And these are done analytically by the system. So it will put them into these buckets. And it will do that for every product, in this case, for every product, for every distributor at every distributor store. In this case, our distributors are the retailers themselves. Now, when we look at an early stage graph, I'm using 20 months of data here just to show you, it's easy to show you this graphically. The green bars are last year and the black bars are the current year. And we can see that our black bars accelerate way past, especially in the middle of the year, way past of the prior year. So we're in an early stage. Our product growth is still accelerating. If we look at the adolescent stage, we see our growth is slowing. We see that there's less growth year over year here, and the acceleration is more muted over here. So again, here's our early stage growth, zooming up, still zooming up. And here's our adolescent stage, now leveling out, not as strong in the acceleration part in the middle of the year. Now, from adolescent, within each stage, we have two other things. We have increasing growth in the units sold. And what does that mean? If we're in a particular stage, like this case, the adolescent stage, increasing growth to the particular retailers and the particular products means that they're solidly still within the analytic stage. But in the other segmentation, we have declining growth. And that looks like this. Now we see very different view. And the black bars, you can see at the beginning of the year, are mostly, except for this one, running behind last year. And where we had accelerated growth in the middle of the year now is very muted. And what this is telling us is that for this distributor, for these stores in Denver, Philadelphia, Phoenix, and Seattle, with these products, these adolescent products are now flipping from the adolescent stage and moving into the mature stage. So now we may have a decision to make from a promotional standpoint. Do we want to run some promotions or discounts to keep these in the adolescent stage? Or do we want to let them move into the mature stage? And again, in the mature stage, we're going to have increasing growth, which means they're solidly mature, and declining growth, which means now they're moving into the end of life. So with this detailed life cycle analysis, we can more intelligently plan our manage our channels and plan our promotions and discounts to maximize our profits. So as time goes on, as we certainly get to our mid stage in the life cycle of our adolescence, We now build sufficient data where we can go from our selected surrogate, the data that we were using as a surrogate, and we can flip over now into full artificial intelligence forecasting. We still use our triangulation, we still go through our simulations, and we still go through our modern monitoring and our comparison of actual and forecast, and of course our life cycle analytics. So the rest of it stays the same. When we do this, and as we go through the NPI life cycle, as well as when we're moving midway and out of our adolescent stage into our sustaining stage, what we're going to find is when we do this, we have actual performance that closely aligns with our plan. Now, in a Lights platform, this is built in and automated. It's intuitive. As I said before, our user interface is intuitive. It's not a no-code. We actually say it's a zero-code environment. You don't need data science or statistics skills, and you don't need IT support. But you may say, but Robert, my IT requires us to use, let's say, Power BI. Can I use that? Well, yes, you can. You can use that. But you're probably going to need someone with statistical skills and someone who knows how to program in Power BI. And it's going to take longer. A good example is a Fortune 500 company that actually moved to better forecasting. It took them about a year using Excel and Power BI to come up with a statistical formula that would fit their division very nicely. But that was a year in development. You did need some statistical help for that. And then it was a 3-year project after that for IT to incorporate it in SAP. But the results were good. So the moral of the story is you have to bring the right tools to solve these kind of, or to bring these tools for the right solution, which is probabilistic forecasting and scenario planning. Some are easier than others, some are harder than others, but don't bring a hammer to a job where you need a pipe wrench. Now, I want to show you an example of AI forecasting and how powerful it is. All AI forecasting is powerful, and it's better than anything that you're doing in your demand planning systems or ERP systems, or your planning tools, or your BI tools, or your data visualization tools, or your spreadsheets. And here's just one example to show you. What we have here is a $750 million CPG manufacturer. This is the results forecast of a forecast made 1 year in advance. So this is a 1-year forecast, and the maroon bars are showing us the results for one particular customer. And the results are running with an accuracy ranging from about 90% to 99% each month over the 12-month forecast. The blue line that you see is what the manufacturer wanted. He wanted an 80% accuracy threshold. In this case, using Lights, we had an AI forecast made 1 year in advance that had an average accuracy of 95%. Now, this was compared to the same 1 year in advance forecast that was done by their demand planning, state-of-the-art demand planning software. And we'll see that the accuracy of demand planning software was about 49% low to about a 78% high. On average, it was 65%. And that's what we're going to get out of our enterprise systems. About a 35% error, 65% accuracy. Now, the difference between having a 95% accuracy and a 65% accuracy is $90 million in inventory reduction. And that's the inventory source for sourcing inventory, finished goods, and E&O. So that's $90 million with higher accuracy that can be repurposed to help grow the company. So what are the gains? Let's kind of put this all together, the gains from probabilistic forecasting and scenario planning. And I like to make it akin to a treasure map. And because it is a treasure, you are finding treasure. You can reduce your forecast error 4 to 8x in this method. You can gain clarity, and as we saw, granularity to get the right products at the right place at the right time. We're going to have confidence to commit and ship to a forecast. We're going to mitigate the gut feel, and we're going to mitigate the decision-making by spreadsheets. With that, we're going to reduce by 2 to 5x material shortages and excess inventory. And that's all going to lead us to drive down costs and margins up by 15 to 35%. So you have a choice. You can continue doing what you're doing with spreadsheets and gut feel. You can continue doing what you're doing with data visualization tools and planning tools and demand planning tools and gut feel. So you can continue doing that. Or you can move to probabilistic forecasts, scenario planning, and using analytic tools. And as we just mentioned, you can reduce your demand forecast error 4 to 8x. You can lift your profits 15 to 35%. You can make decisions with less effort through automation, and you're going to have a higher confidence level as well. Now, for those of you on our webinar today, we will have two spots where we will do a free, no obligation proof of concept with your data. It takes about a week in elapsed time and about 4 hours of your time to collect the data. And then we'll actually test it and see what the results are in your environment. And so with that, if you need to get a hold of me, ask questions, or to sign up for our proof of concept, here's my contact information, my email, and the Aurora website. Now we do have a couple of minutes, and I want to take this time and just go through a couple of questions that are pretty typical. And one of the questions is, how much data do I need? Well, again, when you're doing your surrogate, you'll need 2 years of the surrogate's data. So from the time you released it to the time you retired it. So figure about 2 years. Could be a little bit more, could be a little bit less, depending, of course, on your product life cycle. I mean, if you have a 6-month product life cycle, 2 years is obviously irrelevant. But if you have a 10-year product life cycle, then 2 years is very relevant. Another question is, my data isn't perfect. Can I still do probabilistic forecasting and scenario planning? And the answer is yes. And I can tell you, in over, as I said before, I've done over 1,000 analytics projects. I can tell you with very rare exception, the data wasn't adequate. Now, that doesn't mean the data is perfect, but you don't have perfect data. And we oftentimes make imperfect decisions in an imperfect world with imperfect data. We do the best we can. But by the way, as we use analytics, as we do analytics, the more we do it and the more we use data, the more we find bad data and the more we fix bad data. So analytics is a great way to clean your data as well. So unless you're one of the very rare cases, you do have enough data and it is sufficient. Now, the other question is often asked is, well, I don't have a data scientist. Well, and again, in a lights environment, you don't need a data scientist, but in other environments, you will need a data scientist. Now, and IT support. Now, again, you may have them internally, but you may have to hire them as well. But don't let that be an impediment to doing it, because probabilistic forecasting and scenario planning has enormous benefits. It can free millions, tens of millions, and hundreds of millions of dollars for better use in the company. It can lift your customers' satisfaction because you're getting the right product in the right place at the right time, and it makes you more profitable. So with that, thank you very much for being here. and we hope to see you soon. Now, for any questions that I didn't get to, I will get to an email back to you. So thanks so much for being here, and have a great day.